A 200 kVA transformer with impedance of 5% and the power factor of the load is 85%. The primary voltage is 6,000 volts while the copper loss is 5 kilowatt. Find the percentage regulation. First, we have to list all the given data. We are asked to find the percentage regulation. Percentage regulation is equal to the square root of cosine theta plus percent IR parenthesis squared plus sine theta plus percent IX parenthesis squared minus 1. First, we have to find the value of percent IR. Percent IR is equal to the copper loss over the kVA rating of the transformer. Copper loss is 5 kilowatt over the 200 kVA equals 0.025. So percent IR is 0.025. Next, we have to find the value of percent IX. Percent IX is equal to the square root of percent IZ squared plus percent IR squared. Substitute the value. Percent IR squared is 0.05 plus the percent IR is 0.025 equals 0.0433. So percent IX is 0.0433. Cosine theta is equal to 0.85. So by getting the value of theta, we can also get the value of sine theta. (31.788 degrees). Theta is 31.788 degrees. Okay, for the sine theta, sine of 31.788 degrees is equal to 0.5267. Now that we have all the values, we can now use the previously given formula and substitute our obtained values. So percent regulation is equal to cosine theta plus percent IR squared plus sine theta plus percent IX parenthesis squared minus 1. Substitute. Cosine theta is 0.85 plus percent IR is 0.025. Sine theta is 0.5267 plus percent IX is 0.0433. So the percentage regulation is 0.0443. Since the required is percentage, so we have to multiply it by 100. So the percentage regulation is 4.43%.
The eddy current at hysteresis losses of a 4000 volt 60 Hz single-phase distribution transformer are 280 and 560 watts respectively. Determine the core loss when the transformer is connected across a 4600 volt 50 Hz source.
List first all the given data. The problem asks us to determine the core loss when the transformer is connected across a 4600 volt 50 Hz source. So the required is the core loss. We have first to solve the Ke, or the proportionality constant of eddy current. When E is equal to 4400 volts, and the frequency equal to 60 Hertz. Eddy current is equal to proportionality constant times E squared. So since the eddy current is given, substitute 280 equals, we have to find the proportionality constant, or the Ke. Use the first value of E, 4400 volts squared. Divide both sides with 4400 squared. Cancel. So Ke is equal to 14.463 times 10 raised to negative 6. hysteresis loss is equal to the proportionality constant of hysteresis times e raised to 1.6 over the frequency raised to 0.6. Substitute 560 equals the proportionality constant of hysteresis times 4,400 raised to 1.6 over the frequency of 60 raised to 0.6. First, cross multiply 560 times 60 raised to 0.6 equals kh 4,400 raised to 1.6. Then divide both sides by 4,400 raised to 1.6. Cancel. So kh is 9.673 times 10 raised to negative 3. Okay. Since we have now the proportionality constant of eddy current and hysteresis loss, we need to find the eddy current when E is equal to 4,600 volts and the frequency is equal to 50 Hertz. The same formula, P eddy equals the proportionality constant times E squared. Use the value of proportionality constant of eddy current 14.463 times 10 raised to negative 6 times 4,600 squared. Eddy current is 306.037 watt. Same formula for hysteresis loss. Hysteresis loss is equal to kh times e raised to 1.6 over f raised to 0.6. Substitute the value 9.673 times 10 raised to negative 3. Use 4,600 as the value of E raised to negative 6, raised to 1.6, and F50 raised to 0.6 equals. So the hysteresis loss is equal to 670.798 watt. So now we can solve the core loss. Core loss is equal to eddy current plus the hysteresis loss. Eddy current is 306.037 plus 670.798. So core loss is 976.0 835 watt.